Hi Algebra 2 Honors students. So this video is going to be a lesson all about matrices. Before I dive into the video, I want to explain to you why we're even doing matrices. So matrices are going to be a very useful tool for solving systems of equations. You'll get a lot of systems of equations questions on your SOL, so you'll be able to use this, and you will be responsible for this material on your final, so make sure that you're paying close attention. Now I'm going to go pretty quickly through this video, so remember to pause where you need to work on some practice problems, as well as answer any of the questions on that puzzle. Okay, so let's get started. So first off, we have to define what a matrix actually is. So matrix is the singular form, plural form matrices. So the dimensions of a matrix are told by the number of rows. When you read a matrix, you always want to read it by its rows and columns, okay? So, for example, here we have how many rows? Two across, and we have 1, 2, 3 columns. So our dimensions, we say rows by columns, 2 by 3. Now, what's in the matrix, the numbers are called entries. So the entry in the second row and third column, we look second row, 1, 2, 3, third column, that would be 5. Here, there's lots of different types of matrices. You can get a row matrix, which is just where you have one row. So write down any one row of numbers you want. You can have a column matrix, where you have one column. Right, so any numbers you want in one column. Square matrix is when you have the same number of rows and columns, and then a zero matrix is where all entries are 0. Okay. Now, today what we're going to go into is matrix operations. So we're going to learn how to add and subtract matrices, as well as how to multiply. Now, for addition and subtraction, matrices must have the same dimensions, so the same number of rows and the same number of columns. If they have the same dimensions, then you add or subtract the corresponding entries. So, for example, you would add the second row, second column number to the second row, second column in the second one. Okay, and I'll show you how to do that. And then we also have scalar multiplication. So that's where there's a constant on the outside of the matrix, and you just multiply that constant by every entry inside the matrix. So let's do some examples so we can see. Alright, so perform the indicated operations. So here we have our rows 2 by our columns 3. So these are two 2 by 3 matrices, right? So our answer matrix is going to have the same dimensions, the 2 by 3, because we're just going to add the corresponding entries. So to add this, what we're going to do is we're going to take 6 and we're going to add it to negative 10. So it's going to be negative 4. That's our first entry, right? Then we're going to have 5, and we're going to add 8 to that. 13. Negative 2 plus 13, 11. Negative 3, negative 9, negative 12, so on and so forth, right? So you're just adding the same entries together. Okay. So now, with number 2, we have subtraction. So pause the video and try to just subtract the entries. You should get 6, 10, negative 2, and 1. Okay? Make sure you're careful with the 0 minus negative 1. That becomes positive. And how would you describe the dimension of these matrices? Well, they're both 2 by 2 matrices. So the answer is going to have a 2 by 2. Okay, great. So here, number 3, that's our scalar multiplication. This is where we have a constant on the outside of the matrix. And if you remember from the previous page, what we do is we take that constant and we multiply it by every entry inside the matrix. So 3 times negative 2, negative 6. 3 times 0, 0. 3 times 4, 12. 3 times negative 7, negative 21. There you go. And the dimension of this matrix is a 2 by 2. Alright, number 4, we're combining. So when you have scalar multiplication, what you first want to do is write that new matrix, and then you're going to add the next one to it. So multiply out negative 2 times this first matrix. You should get negative 2, 4, 0, negative 6, 8, and negative 10. Okay, did you remember that it was a negative matrix? Hopefully you did. And then our second matrix stays the same, and then you just add them together. So corresponding entries you add together. So you should do negative 2 plus negative 4, 4 plus 5, 0 plus 6, and so on and so forth. Pretty simple so far, right? Ooh, what are the dimensions of these matrices? Here we have Remember, it goes columns by or rows by columns. So we have 3 rows, 2 columns. So 3 by 2. All right. Number 5, I'm going to let you try. Actually, number 5 is a bit trickier, actually. So number 5, we're going to be solving for x and y in our matrix. Now, if we only care about x and y, we're just going to solve for those specific entries. So here, what I can do, this 2 is being multiplied by this matrix addition, and we only care about where the x is and where the y is. So we can write equations to represent those entries. So we know, if we start with our order of operations, PEMDAS, right? We know we have to do the parentheses first. So we're taking 3x and we're adding 4 to that. And then with that, 3x plus 4, we're going to multiply that by 2 and set that equal to 26. So here's the first one. So this is kind of what I said out loud, right? Take 2, you multiply it by that quantity, 3x plus 4, and set that equal to 26, right? Because this is saying when you multiply these, or when you add these matrices and multiply by 2, you should get 26 in the first one. So then you can go through the process of solving for x, and you get x is equal to 3. So now I want you to pause the video and try it for y. So here's what you should have done when you solve for y, and you should have gotten y is equal to 1. Alright, so that's addition and subtraction and scalar multiplication, where you're multiplying by something on a constant on the outside of the matrix. Now we're going to actually multiply matrices. Now for this, you might want to get out your calculator. Well, you definitely will want to get out your calculator. So for matrix multiplication, we're looking at how do we multiply 2 matrices. In order to do matrix multiplication, what has to be true is that the number of columns in the first matrix must match the number of rows in the second matrix. So let's say we have 2 matrices, A and B. A is an m by n matrix, meaning that it has m rows, n columns. B is an n by p matrix, meaning n rows and p columns. What do you notice is the same about each of these is that these n's, these middle numbers, are the same. So what happens is that if we cross 2 matrices and we kind of just cancel out the middle, cancel out what's the same about them. And then we're going to end with an m by p matrix. So m rows and p columns. Alright, let's do some practice with matrix multiplication. So here, 2 by 3, and we're multiplying that by a 3 by 4. What do we notice? Well, we notice that we have a 3 and a 3, so we can indeed multiply these matrices. So what is our final result? It's going to be a 2 by 4. We cancel out those 3's. Oh, there it is, and it's a 2 by 4. Now B, 3 by 2 and a 3 by 4, what do you notice? Uh-oh, 2 is not equal to 3, so therefore this is not possible. Alright, these 2 numbers have to be the same to do matrix multiplication. So we can't. Alright, so here we're actually going to start multiplying matrices. We're going to use our graphing calculators to do this though. And this is going to be super simple and make your lives pretty easy to do. So go ahead and open up your calculator. Grab that. Alright, here's my calculator. So I have a large screen here so you can follow along with me. So what we are going to be using, I'm going to put it over here so I can see the problem. If you do second and then it's this x to the -1 button, you'll see that the blue, it says matrix. That's what we want to use. Now when you open yours, it'll probably be blank. I've already kind of been using this a little bit, so that's why I have some numbers here, but you should probably just have A, B, C, D, so on and so forth. Okay? Kind of like what we do for stat edit, we're going to edit our matrix. So we're going to go over to edit and press enter. And we're going to start entering in our matrix A. So we're going to enter in this matrix. Now first you have to give the dimensions. So remember it's rows by columns. So this is a 3 by 2. Enter. So now you're going to enter in the correct values. -2. Oops, what did I do? Okay. I'm glad I made this error because this is probably an error a lot of you will make. Is this a negative sign right here? I was typing it on my computer and it's actually a subtraction sign. You really want to make sure that you're using that negative sign. So -2, 3, 1, -4, 6, 0. Okay. Then that's your matrix A. So you're done with that. So then go second matrix again. And now over to edit, we're gonna now put in matrix B. Now what dimensions do we have for matrix B? It's a 2 by 2. You'll enter in those values as well. Make sure you're putting in the correct entries into these, right? And then you'll do second quit to get out of the matrix. So now we want to multiply these two. To multiply that, you're going to do second x1 matrix again, and you're going to do, whoops, that's not what I wanted. Your second matrix, number 1, so A, and then second matrix, number 2, B, enter. And there we have it. -4, 6, 7, let's see, that is what I had, right? So you should have been able to get that on your calculator. Okay, so it's really simple with the calculator, and I'll show you another example. Make sure you're writing in those dimensions to make sure that you get the correct, that you can actually do matrix multiplication. So now let's do it backwards. B times A. So we're using the same matrices, right? But if we were to reverse it, and instead of doing A times B, if we did B times A, let's see, second x1, number 2, B, second x1, A. Ooh, what happened? Why did I get this error? Can you think about it? Well, it's because it's not possible. 3 rows by 2 columns, two rows by 2 columns. If I reverse that, if I switch it, then the number of columns of B is not equal to the number of rows of A. Dun dun dun, we can't do it. Okay, no matrix multiplication there. Alright, moving on.